Hey everyone, this is Mr. Bowman. Welcome back. And this is the second problem from the AP Calculus free response review that focuses on the fundamental theorem. This is a no calculator problem, so let's see what we're given here. We're given a graph of f prime. The figure above shows the graph of f prime. The derivative of a twice differentiable function f on the closed interval from 0 to 8. Notice it's twice differentiable, meaning that the function is differentiable and the derivative of f prime is also differentiable, which also implies continuity for both f prime. On the closed interval means we include the endpoints. The graph of f prime has horizontal tangent lines at x equal 1, at x equal 3, and x equal 5. So slope of the tangent line is 0 at those x values. The areas of the regions between the graph of f prime and the x-axis are labeled in the figure. The function is defined for all real numbers and satisfies f of 8 is equal to 4. Okay, so even though the area shown below the x-axis is a positive number, if we were to integrate over that interval from, what would that be, from 3 to, from 4 to 6, that integral would be negative. All right, so let's see what they're asking us. In part A, they say find all values of x on the open interval, not including the endpoints, for which the function f has a local minimum. Justify your answer. All right, so it would go something like this. F has local minimums on 0 to 8 where f prime changes negative to positive. So where would that be? At x equal 6 is where f prime changes negative to positive up there on that graph. So let's jump over to the scoring rubric, take a look at what they would expect. It says 1 point for answer with justification. I would say if you did not have a justification, you will not get that 1 point. Back over to the question, it says determine the absolute minimum value of f on the closed interval from 0 to 8. So we want an absolute minimum, and the closed interval includes the endpoint. Justify your answer. All right, so here's where we need to make the candidates chart for x and for f of x. So we've got x, f of x. We are going to include the endpoints of 0 and 8, so 0 and 8. But we're also going to include 6 because we know that that's a local minimum. So now we have to evaluate the function f at all of those values. Here's where the fundamental theorem comes in. We know that the integral from 8 to x, and the reason I picked 8 is because we know f of 8 is 4. The integral from 8 to x of f prime of t dt is equal to f of x minus f of 8. So if we were to solve that for f of x, we would know that the integral from 8 to x of f prime of t dt plus f of 8 would be equal to f of x. And that's how we can find f of 0 and 6 and 8. Now, I don't like to integrate backward, so I'm also going to rewrite this using this option. If we switch the limits of integration from x to 8, we can say that, and put a negative in front of it, we can say that this plus f of 8 is equal to f of x. So now we have to evaluate the integral. All right, so here's an example of why I like to change this so that when we're using limits of integration that are lower than 8, it's easier for me to think about. So I'm going to integrate, so if I want to find f of 0, I'm going to integrate from 0 to 8 f prime of t dt, and then I'm going to put a negative in front of it, and then I'm going to add f of 8. But I already know f of 8 is equal to 4. So to get the integral from 0 to 8, I'm just going to look up top here at the graph, and the integral from 0 to 8 is going to be the following. It's going to be 2 plus 6, which is 8, minus 3, which is going to be 5, plus 7, which is going to be 12, and we have negative 12 plus 4, which is equal to negative 8. So f of 0 is equal to negative 8. Plug that number in. F of 6, we're going to do the same way. So f of 6 is equal to the opposite of the integral from 6 to 8 of f prime of t dt plus 4. So we go back up to the graph. The integral from 6 to 8 is positive 7. We're going to put a negative in front of that. So we have negative 7 plus 4, which is equal to negative 3. So f of 6 is equal to negative 3. And then finally, we're going to find f of 8. Well, we already know f of 8. It is positive 4. They gave that to us. If you verify it with the integral, you're going to have the integral from 8 to 8 of f prime of t dt, and then a negative in front of it, but that integral turns out to be 0, so f of 8 is equal to 4. And from our candidates chart, f of 0 equals negative 8 is the absolute minimum on the closed interval 0 to 8. So let's jump over, take a look at the scoring for that. And in part B, it says you consider x equals 0 and x equals 6. You have an answer and you have a justification. So f of 0, f of 6, f of 8, the absolute minimum is negative 8. For part C, it says on what open intervals contain for x between 0 and 8 is the graph of f both concave down and increasing. Explain your reasoning. So f is concave down, f concave down when f double prime is less than 0. Another way of saying that is f prime is decreasing, and I would refer it to f prime instead of f double prime because we're given a graph of f prime. F is increasing when f prime is greater than 0. Okay, so we are looking for the intervals on the graph of f prime when it is positive and decreasing. So that is happening here, and it's also happening here. So those intervals consist of, let's see, 0 to 1, open interval it said, so we're not including 0, or 3 to 4. Let's jump over and take a look at the scoring rubric and see what they're looking for there. The graph of f is concave down and increasing on 0 to 1 and 3 to 4 because f prime is decreasing and positive on these intervals. Notice that they referred everything to f prime because that's what we're given the graph of. And then finally, the last part says, the function g is defined by g of x equals f of x to the third. If f of 3 is equal to negative 5 halves, find the slope of the tangent line to the graph of g at x equals 3. All we have to do is find the slope of the tangent line to g at x equals 3. So literally, we just have to find g prime of 3. So g of x, I'm going to rewrite that here, g of x is equal to f of x to the third power. So g prime of x is equal to 3 times f of x to the second times f prime of x. Basically, we're using the chain rule here. So g prime of 3, the slope of the tangent line to g at x equals 3, is 3 times f of 3, quantity squared, times f prime of 3, which is equal to 3 times f of 3 is given as 5 halves. We're going to square that, times f prime of 3. We're going to have to read off the graph, and f prime of 3, if you go up to the graph, f prime of 3 is equal to 4 from the graph. So we're going to go back here and plug 4 in. That's our answer. We're going to go ahead and simplify this. So 3 times 25 over 4 times 4. 4's cancel. We get 75. And as far as scoring is concerned, 2 points for the derivative. I would imagine 1 point for this portion right here. That seems pretty generous. And 1 portion for that part right there. And then evaluating it, or 1 point for the actual derivative, 1 point for plugging the values in, and then getting the answers, even if you did not simplify it.